welcome to our developmental psychology video. This is for our OCR GCSE theory number 1. This is our supporting evidence, and this is Piaget's study into the conservation of number. So this is the study that supports the idea that our children develop in stages, and Piaget put together a list of 4 stages that he believed all children move through in a universal way. So this study is one of the many studies that Piaget did to support his idea of these 4 stages. It focuses on the idea of conservation, and it's looking at the stage that children go through when they are then able to do the skill of conserving. So the 4 stages that Piaget put forward were the sensory motor stage, the pre-operational stage, the concrete operational, and the formal operational. So the ones that we're particularly interested in today are the pre-operational and the concrete operational. And the reason why we're interested in these is because this is the stage where children go from not being able to conserve to being able to conserve. So this is where we will see that skill develop at some point in these stages. Okay, so just a quick recap of what conservation is, because you need to be able to describe this to try and understand what the study is looking at. So if you can get your head around this idea of conservation, you'll understand the study a little better. So this is one of the cognitive abilities that Piaget was looking at in these stages. Now, don't forget, this is a really good explanation in how we get these cognitive abilities, but it does fall down slightly because it doesn't show us how we develop them or what changes in the brain when we've got these skills. So that bit is probably still to come with more advanced brain scanning techniques. But for Piaget in the 1950s, this was obviously a fantastic start to explaining the developmental ability of children. So conservation then. So when children are able to understand that if an object changes shape, the physical characteristics, the physical properties of the object don't change, then they are able to conserve. So for example, the picture at the top we've got is this young lady looking at 2 beakers of water. It's very clear from the first picture that they are exactly the same amount of water. However, when one is poured into a different shaped beaker and she's asked which one has the most water, she's pointing to the taller beaker rather than thinking about how much was in it before. Has it changed? No, it hasn't changed. And which one has the most now? Now, the interesting thing about this skill is even when children see the transformation, they still can't make the conservation. So they still can't see that they have the same amount of water, the same amount of liquid in. Same when things change shape. So we've got some plasticine here. So we can take the ball and we can roll it into a different shape. And if a child isn't able to conserve, then they will think that that shape has a different amount of plasticine in it. So it's a very clear indication whether they have the skill or not. So the aim of this study then is to have a look at the stages that this skill develops in. Now, Piaget has already put forward the theory that as we go through the pre-operational stage into the concrete operational stage, we should have this. This is one of the milestones that children should be able to do. Now, he specifically chose counters, numbers, to focus on for this because number conservation is the first of the conservation skills that children develop. Once they've got number conservation and they understand that numbers stay the same, then they gather the ability to conserve mass, which is weight, and volume, which is the water one we saw before. So in terms of hypothesis, now don't forget this is sometimes called our experimental hypothesis, and this is children in the concrete operational stage will be able to conserve, whereas children in the pre-operational stage will not. Don't forget, it's very important to have our independent variable and our dependent variable in our hypothesis. Now, in this one, the independent variable is the age of the children. Now, although that isn't sort of stated in the hypothesis, the stage is stated in the hypothesis. So we're not after the exact age, we're after the stage the children are in. And the dependent variable is the ability to conserve or not. So to test this, Piaget did a natural experiment. So it's one of our experimental methods. Now, just remember that this is a natural experiment because we cannot change the independent variable to manipulate which children go in each group. And the reason why we can't do that is because it's the children's age. It's naturally occurring, we're taking advantage of that naturally occurring variable, and they are put into the independent variable groups dependent on that. So it's not something we can change. That's where the natural experiment comes from. So we have an independent variable of the group of the child. They're split into two groups of those that come in the pre-operational stage and those that come in the concrete operational stage. So we've got two different levels of IV split by age. It's got to be independent groups. We can't do repeated measures because the children can't take part in one condition and then take part in the other condition because they can't change their age. So some of these questions, when you get easy questions like this on the exam, it is just a case of thinking about these things logically. Can it be repeated measures? No, because a child can't take part in both conditions. So just think them through logically. A dependent variable is their ability to conserve, and that's a simple yes or no. Now, the sample for this study was a group of children from Switzerland, which is where Piaget was working at the time. He didn't recall the exact number, so we'll just have to say the sample was Swiss children. The interesting thing about this was it included Piaget's own children, and lots of Piaget's work centred around the abilities of his own children and the stages they were going through, so they very often took part in his experiments. Okay, so the method then. What happened during the experiment? This is probably the most simplest study that we will look at in the 2 years, so it should be quite easy to get your head round. So the children are shown the top picture, picture A. It's got counters all rayed up directly above and below each other, so it's very clear that there's the same amount of counters taking up the same space. Obviously we know that because we've moved through these stages successfully. So the children were asked, so showing picture A, and they were asked, is there the same number of counters in each row? And you would imagine that the majority, hopefully all, would say yes, there is. The experimenter then moved the counters on the bottom row so the children could see the transformation, and they spread that bottom row of counters out so they took up more space. So they haven't added anything, they haven't taken anything away, and the children have watched them transform it. So they're then asked again, is the same number of counters in each row? And the children either answered yes, there was, or no, there wasn't. And that answer determined whether we thought they were in the concrete operational stage or the pre-operational stage. Okay, so results then. So we can see from the results that the children in that pre-operational stage tended to say that the counters had spread out. Sorry, they did to say that the spread out line had more counters. So these were the children that were aged about 3 to 4, which was Piaget's prediction of children in that pre-operational stage. Now, he did note that the children towards the end, the 5 and 6-year-olds who were moving towards the end of the pre-operational stage, were able to say that that had the same amount of counters in the bigger row, but they weren't able to justify logically what had happened. Okay, so they could say it was taking up more space, but they couldn't really articulate that it was because the same amount of counters had been spread out. They just said, no, there is the same amount. So they were able to sort of do half of it, but not quite all of the conservation. And it just shows that this gradual move from one skill to the other, it's not a case of it's instantly there. The age 7+ children who would be comfortably in that concrete operational stage, they were able to say that both lines had the same amount of counters, and they will also be able to sort of explain the logic behind it. So very clearly articulate that it's the same amount of counters, you've just spread them out more. So they were able to articulate that very well. Okay, so in terms of conclusions then, what we really need to know is, does he accept his hypothesis? Does he support what he said he was going to find? And does it support his theory? So in both cases, we can say yes, it does. So he's able to accept his hypothesis. He did find that children in that concrete operational stage were able to conserve those numbers better, and the children in the pre-operational stage, especially the early stage, were not able to conserve numbers at all. Okay, so in terms of supporting his theory, this piece of research supports this idea of conservation. Now, obviously, it doesn't support all of his theories, but it does able to support that one particular area. So what you would have to do to support each individual area is to go and look at the research for each stage. And obviously, it's very difficult to get one piece of research to support it all because it focuses on lots of different bits and pieces. But for us, it's enough to know that yes, it supports that theory. Okay, so for next lesson, make sure that you can describe the method thoroughly and accurately. Make sure you understand about conservation, what conservation is, what a child who can conserve can do, and what a child who can't conserve can do, and make sure you're completely happy with those descriptions of the stages. Find a way to help you remember them, and make sure you know those key skills that happen in each of the stages. Okay, bye-bye.